close your eyes for a moment and imagine the winter night sky. If you look up on a clear night, you will see one of the most recognizable constellations of all, Orion, the celestial hunter. 3 bright stars form its belt, easily identifiable even in light-polluted urban skies. And above this belt, marking what the ancients imagined to be the left shoulder of the giant hunter, shines a reddish, pulsating ancient star. Its name is Betelgeuse. But calling Betelgeuse a star is almost inadequate. It is a red supergiant, a stellar titan so vast, so immense, that it defies our ability to truly comprehend its scale. Imagine for a moment our sun, that bright sphere that seems so large as it crosses the daytime sky. Now multiply its diameter by 764 times. That is Betelgeuse. It is a star whose vastness is almost incomprehensible. To put this into perspective that perhaps makes more sense, if you could somehow take Betelgeuse and place it exactly where our sun is now, its size would be so colossal that its surface would engulf Mercury. It would continue expanding, swallowing Venus. It wouldn't stop. It would consume Earth, vaporize Mars, and continue growing until it swallowed even Jupiter, the gas giant of our solar system. We would all, theoretically, be living inside the atmosphere of a dying star. Betelgeuse is alive in a peculiar way. It pulsates. Its brightness varies over time, sometimes brighter, sometimes dimmer, in cycles that can last months or years. This is not a defect or anomaly. It is normal. It is expanding and contracting like a gigantic heart beating slowly in space, its outer atmosphere swaying in and out in rhythms that reflect turbulent internal processes. And here's something that should make you pause in awe. Betelgeuse is approximately 550 to 650 light-years away from Earth. The exact distance is still debated, but what this signifies is profound. The light you see when you look at Betelgeuse in the night sky isn't showing the star as it is now, at this moment. It's showing it as it was centuries ago, in the 14th century, when the Black Death ravaged Europe, when the Renaissance hadn't yet begun. You are literally looking into the past every time you contemplate Betelgeuse. And this red giant is dying. It is in the final stages of its stellar life, having burned through hydrogen, helium, and now fusing increasingly heavier elements in its core under unimaginable pressures and temperatures. It is a process that cannot continue forever. Eventually, perhaps in 1,000 years, perhaps in 100,000, Betelgeuse will explode in a supernova, an explosion so catastrophic that for a brief moment it will release more light than all the other stars in our galaxy combined. When this supernova occurs, it will be an unprecedented spectacle in recent human history. Betelgeuse will be so bright in the sky that it will be clearly visible during the day for weeks, perhaps months. At night, it could shine as intensely as the full moon, transforming nights into strange reddish twilights. It would be a cosmic event witnessed by all of humanity, regardless of where you were on the planet. And here's something that should make your skin crawl slightly. Some scientists suggest that Betelgeuse may have already exploded. The explosion may have happened centuries ago, and the light from that cosmic catastrophe is still traveling through the light years of empty space between it and us. We could wake up tomorrow, or in 10 years, or in 1,000, and see a new, fiery star appearing in the sky. Not because it just happened, but because the light finally reached us. Its reddish color is no coincidence or cosmic decoration. It's a direct indicator of temperature. Betelgeuse is cool by stellar standards, only about 3,500 Kelvin on its surface. That's hot enough to vaporize any known material instantly, but for a star, it's positively cold. Hotter stars glow blue or white. Betelgeuse, in its senescence, glows deep red. At the peak of the supernova, when it finally happens, calculations suggest it could shine like a full moon in the night sky. You could read a book by its light. Shadows would be cast throughout the night. For weeks, the night sky would be transformed by this cosmic beacon. Ancient Arab astronomers observed Betelgeuse millennia ago. They named it, and although the exact etymology is debated, many believe the original name meant something like the giant's hand or the hunter's hand, appropriate for its position in the constellation Orion. Betelgeuse is literally evaporating. It is constantly losing mass, ejecting material from its outer atmosphere into the space around it. It's as if the star is slowly bleeding, its substance being ripped away and scattered by the stellar wind, forming a thin haze around it that stretches for vast distances. In 2019, something dramatic happened that captured the attention of astronomers around the world. Betelgeuse decreased dramatically in brightness, more than any variation previously recorded. For a moment, the scientific world thought that perhaps, finally, a supernova was beginning. Telescopes around the globe turned to it, observing, waiting. But it wasn't a supernova. It was something equally fascinating. The star had expelled a huge cloud of dust, which temporarily blocked some of its light from our perspective. It was as if Betelgeuse had coughed, ejecting material that formed a curtain between it and us. For ancient cultures that lacked artificial light and lived much more connected to the rhythms of the night sky, the appearance of Betelgeuse on the eastern horizon at dusk signaled the beginning of winter. It was a celestial time marker, a cosmic clock helping to navigate the seasons. And there is tantalizing evidence, ancient records from various civilizations, that may have documented changes in Betelgeuse's brightness over thousands of years. Texts describing stars changing color or intensity may be referring to the pulsations of this dying giant, observed by human eyes so long ago that the civilizations that recorded them disappeared millennia ago. Breathe slowly. Feel the vastness of cosmic time. Light traveling through centuries just to reach your eyes. The unpredictability of Betelgeuse is both fascinating and frustrating for astronomers. It is so unstable, so close to the end of its life that it could literally explode today, as you read these words. Or it could continue pulsating, expanding, and contracting for another 100,000 years. We simply don't know. It's like watching a clock whose alarm could sound at any moment, but whose inner workings remain partially hidden from our understanding. Betelgeuse is extraordinary in another way. It is one of the very few stars beyond our sun, whose surface we can actually see with modern telescopes. Most stars, no matter how powerful our instruments, appear only as points of light without discernible structure. But Betelgeuse is close enough and large enough that we can resolve details in its disk, bright and dark patches, regions of varying temperature, features that change over months or years. And what we see is astonishing. Its atmosphere is so turbulent, so convulsive, that it seems to bubble like a gigantic boiling liquid. Enormous convection cells, each one larger than our entire orbit around the sun, rise from the depths, bringing heat to the surface, then sink again as they cool. It's like watching a pot boiling, but on a stellar scale. Interestingly, Betelgeuse rotates slowly on its own axis. Stars that rotate faster tend to burn their fuel more quickly, living shorter but more intense lives. Betelgeuse's slow rotation may have prolonged its existence, allowing it to reach the advanced stage of stellar evolution that we now witness. And throughout its life, Betelgeuse was not alone. Studies suggest that it may have had planets orbiting around it, worlds that, as the star expanded into its red giant phase, were swallowed one by one. Imagine entire planets being vaporized, their atoms scattered and incorporated into the atmosphere of the dying star. If any civilization existed on these worlds, it met an inevitable apocalyptic end. What if life exists somewhere near Betelgeuse right now? It's unlikely. Any planet still in orbit would be baked by intense radiation and extreme heat, making liquid water or stable organic chemistry impossible. The habitable zone around Betelgeuse, if it exists, would be so distant that the star would appear as a tiny dot in the sky. Betelgeuse is expanding at an alarming rate. It has already lost approximately 20% of its original mass, ejected into space through stellar winds and mass loss episodes like the dimming event in 2019. It is a star bleeding its substance into the void, slowly consuming itself as it approaches its catastrophic end. And when the explosion finally comes, it will be glorious in more ways than one. The supernova will scatter heavy elements, gold, platinum, uranium, elements that can only be forged in the extreme conditions of a stellar explosion, for light years around. These elements, billions of years in the future, may condense into new planetary systems. Rocky planets with gold in their guts, perhaps future civilizations mining platinum that was created in the death of Betelgeuse. The death of this star may sow the seeds of future life. Theorists also suggest that when Betelgeuse collapses, the event could produce detectable gravitational waves, ripples in space-time created by the catastrophic redistribution of mass. Our gravitational wave detectors could pick up this signal, giving us information about what is happening in the core of the collapsing star that no optical telescope could reveal. If a supernova were to happen within the lifetime of anyone alive today, it would undoubtedly be the most observed astronomical event in human history. Billions of people gazing at the night sky, seeing a bright new star where before there was only Betelgeuse. It would be a unifying moment, a reminder that we share not just one planet, but a galaxy, a constantly transforming universe. Betelgeuse pulsates in complex cycles. Sometimes it dims, its light fading for weeks or months. Other times it shines brighter, as if temporarily regaining energy. These cycles are not perfectly regular. There are multiple overlapping periodicities, creating a pattern of variability that we do not yet fully understand. And its shape is strange. It's not a perfect sphere like we imagine stars should be. Observations show that Betelgeuse is oval, irregular, asymmetrical, like a crumpled ball. This could be due to rotation, gigantic convection processes distorting the shape, or perhaps interactions with surrounding material. And surrounding Betelgeuse is a huge arc of gas, a crescent-shaped structure detected by infrared telescopes. It's like a cosmic shield or a frozen shock wave in space. The exact cause of this arc is still debated. One hypothesis is that it's formed by the collision between Betelgeuse's stellar wind and interstellar hydrogen as the star moves through the galaxy, creating a region of compression and heating. Betelgeuse is one of the most studied stars by professional and amateur astronomers. We have decades of observations, multiple wavelengths, high-resolution images. And yet, it remains full of uncertainties. Each new observation seems to raise as many questions as it answers. When the supernova finally happens, there will be radiation, X-rays, gamma rays, high-energy particles. This radiation will travel through space and eventually reach Earth. But Betelgeuse is far enough away that it won't directly affect us. There will be no extinction, no damage to the ozone layer. It will be a dramatic visual spectacle, but not a threat. And what will remain after the explosion? Some astronomers suggest that Betelgeuse may collapse into a black hole. If its remaining mass after ejecting its outer layers is large enough, gravity could crush the core beyond the point of no return, creating a singularity. Others believe it will become a neutron star, an incredibly dense object where matter is compressed to nuclear densities, where a teaspoon would weigh billions of tons. It would be an exotic stellar corpse, spinning rapidly, perhaps emitting pulses of radiation like a cosmic beacon. We won't know for sure until it happens, and when it does, humanity will have a unique window to study stellar death in unprecedented detail. Let your breathing slow. Feel the slow pulse of this dying giant, expanding and contracting through the centuries. Relax deeply. More mysteries of Betelgeuse await. Recent observations suggest something unsettling. Betelgeuse may be losing mass even faster than previous models predicted. It's as if the star is accelerating toward its end, bleeding its substance into space at rates that defy our expectations. Each new measurement seems to reveal a star more urgently approaching final catastrophe. Its brightness varies so dramatically that it has baffled ancient observers. Historical records show conflicting descriptions of Betelgeuse's luminosity, some calling it extremely bright, others noting periods of remarkable dimming. These were not observational errors, they were real testimonies of the pulsations and variations of this unstable star over centuries. And here's something that should make you pause. The star may be undergoing internal collapse right now. Processes happening in its core, frenzied nuclear fusion, increasing instabilities, mass redistribution, may have already triggered the irreversible cascade that will lead to a supernova. But we are light centuries away, seeing only ancient light. The collapse may have already begun, and we simply don't know it yet. In 2019, Betelgeuse dimmed so drastically that astronomers around the world were on high alert. For weeks, the star lost about 60% of its normal brightness. Professional observatories and amateur astronomers pointed their instruments at it, observing, measuring, speculating. Many thought that finally, after centuries of waiting, the supernova was beginning. The event became known as the Great Dimming. Headlines around the world proclaimed that Betelgeuse was about to explode. Astronomy forums buzzed with speculation. It was a moment of collective anticipation, humanity watching a dying star perhaps take its last breath. The most widely accepted explanation that eventually emerged was that Betelgeuse had expelled a massive cloud of dust, material ejected from its turbulent atmosphere that formed a temporary curtain blocking some of its light from our perspective. When the cloud dispersed, carried away by the stellar wind, the brightness gradually returned. However, not all scientists are completely convinced. There are those who believe that the Great Dimming was a sign of internal nuclear instability, convulsions in the star's core manifesting on its surface. Perhaps it was a harbinger, a warning of what is to come. Because at the heart of Betelgeuse, cosmic alchemical processes are taking place. The star is creating heavy elements within itself: iron, nickel, elements that can only be forged under unimaginable temperatures and pressures. Successive layers of nuclear fusion have created an onion-like structure inside the star. Hydrogen in the outer layers, then helium, then carbon, oxygen, neon, magnesium, silicon, and finally, in the deepest core, iron. And iron is the end of the line. Melting iron doesn't release energy. It consumes energy. When Betelgeuse's core becomes predominantly iron, fusion will abruptly stop. Without the external pressure generated by fusion, nothing will resist gravity. And in a fraction of a second, literally less time than it takes to blink, the core will collapse. Following this initial collapse, a shock wave of unimaginable violence will pierce the star's outer layers in seconds. This wave, carrying energy equivalent to 100 billion atomic bombs, a number so large it loses its significance, will tear away the outer layers and hurl them into space at significant fractions of the speed of light. The resulting brightness would be extraordinary. For a few weeks, Betelgeuse could become brighter than the full moon in the night sky. You could read a book by its light. Children would wake up thinking that day had arrived. And during the day, you could look up at the sky and see a bright star visible, even with the sun above the horizon. Ancient peoples may have witnessed similar events. There are intriguing records in cave paintings, ancient texts, and oral traditions that describe new stars appearing in the sky. Some may have been supernovae, observed by cultures that did not have the modern scientific language to describe them, but who recorded them in art and myth. And after the explosion, the story of Betelgeuse would continue in ways we are only beginning to imagine. New nebulae would form around the remnant, bright clouds of gas and dust enriched with heavy elements created in the star's death. These nebulae, over millions of years, could collapse under their own gravity, forming new stars, new planetary systems. Rocky planets born from matter that was once part of Betelgeuse. The explosion could send jets of matter in opposite directions, sheets of plasma traveling at relativistic speeds, cutting through the interstellar medium like cosmic knives, creating structures that would persist for millennia. And there's the possibility of gamma radiation, bursts of gamma rays that are some of the most energetic phenomena in the universe. Fortunately, Betelgeuse's current rotation angle suggests that any jet of gamma rays wouldn't be pointed directly at Earth. We are, it seems, out of the line of fire. Even so, the supernova could temporarily influence Earth's magnetic field, create more intense auroras, perhaps even briefly disrupt satellite communications. Nothing catastrophic, but remarkable. A physical touch of a distant cosmic event. And after the explosion, after the nebula expands and disperses, after millions of years, what remains of Betelgeuse, whether a black hole or a neutron star, may become just a cold, dark point in the cosmos. A stellar corpse, invisible except for its gravitational effects, floating silently through the galaxy. A monument to stellar mortality. Breathe slowly. Imagine this cosmic forge, creating elements in the incomprehensible heat of its core. To truly comprehend the vastness of Betelgeuse, we need analogies that make the incomprehensible at least imaginable. If you were to shrink the sun to the size of a soccer ball, something you could hold in your hands, Betelgeuse would be an entire stadium. Not the ball inside the stadium. the complete stadium with all its stands, roof, structure. It's a difference in scale so vast that it defies intuition. Betelgeuse's radius is approximately 700 times greater than that of the Sun. This means it is so large that light, traveling at 300,000 kilometers per second, the fastest speed imaginable, takes more than an hour just to traverse its diameter. Consider this. Light that crosses the Earth-Moon distance in just over a second would need more than an hour to travel from one side of Betelgeuse to the other. And despite this vastness, its average density is incredibly low. Betelgeuse is almost a hollow star. Its outer layers are so diffuse, so tenuous, that they are practically a vacuum compared to any planetary atmosphere. But in the core, the story is completely different. A teaspoon of material from Betelgeuse's core would weigh more than a terrestrial mountain. Matter compressed to densities that only exist in the final stages of stellar evolution. The surface of this red giant is a turbulent inferno. Gases rise and fall in massive convective cells, plasma eruptions the size of solar systems, rising from the depths, cooling, then sinking again. It's like watching an ocean of fire in cosmic slow motion. Its reddish color indicates a relatively low temperature compared to the Sun, only about 3,500 degrees on its surface, while the Sun is around 6,000 degrees. But this relative coolness is deceptive. Despite being cold by stellar standards, Betelgeuse produces about 100,000 times more energy than our Sun. It is a cosmic furnace of unparalleled scale. Betelgeuse holds a special place not only in astrophysics but in human culture. It is part of Orion, specifically marking the shoulder of the celestial hunter, one of the most recognizable asterisms in the night sky. For millennia, humans have looked up and seen Orion in the African savannas, the American plains, the deserts of the Middle East. It is a constellation that transcends cultures. Ancient civilizations used the brightness and position of Betelgeuse to predict seasons and plan harvests. Its appearance in the eastern sky at dusk signaled seasonal changes, times to plant or harvest. It was a celestial clock, reliable most of the time, but occasionally variable in ways that must have confused and perhaps frightened ancient observers. Some indigenous tribes believed that the dimming of Betelgeuse was an omen, a sign of coming changes on Earth, warnings from celestial spirits. When the star diminished in brightness, it was a time for caution, for preparation, for rituals to appease forces beyond comprehension. The star may have been the center of now-lost legends about giant gods, cosmic beings whose life and death shaped the universe. Fragments of these stories may survive in myths that we no longer recognize as having astronomical origins. In many ancient cultures, the intense red glow of Betelgeuse was associated with war and bloodshed. It was a martial star, a symbol of conflict and violent passion. Ancient astrologers saw its fluctuating brightness as a reflection of earthly tensions, impending battles, and prophesied bloodshed. Modern science confirms that Betelgeuse has already lost a substantial amount of its original mass to space. Perhaps 20, perhaps 30%. This material does not disappear. It forms a huge cocoon around the star, a haze of gas and dust stretching over vast distances. This cocoon may have been partly responsible for the great dimming of 2019. When Betelgeuse ejected a particularly dense cloud of dust, this material added to the existing cocoon, temporarily blocking more light than usual. Careful observations reveal that Betelgeuse is not stationary in space. It is moving, traveling through the galaxy like a ship crossing a cosmic ocean. And as it moves, its stellar wind interacts with the interstellar medium, creating a shock wave, a trail that can persist for millions of years after the star itself has exploded and disappeared. When Betelgeuse explodes as a supernova, it will undoubtedly be one of the greatest astronomical spectacles ever witnessed by civilized humanity. There is no reliable record of a supernova so close and bright in written history. It would be a generation-defining event, perhaps even one that defines multiple generations. And some speculate that such an event could have profound impacts beyond astronomy. It could inspire works of art, literature, music. It could influence religions, create new spiritual interpretations of the cosmos. It could trigger scientific revolutions as astronomers suddenly gain access to unprecedented data on stellar death. A cosmic event becoming a catalyst for human cultural transformation. Imagine this dying giant, larger than a stadium if the sun were a ball, slowly pulsing through the centuries, awaited by thousands of human eyes. Relax even more deeply. We are approaching the final revelations about Betelgeuse. There is a possibility that should make you pause in awe and unease. Betelgeuse may have already exploded. At this very moment, as you read these words, resting comfortably, the light of this cosmic catastrophe may be traveling through the light years of emptiness between it and us. A wave of photons carrying the visual news of a star's death, traversing the galaxy at the maximum speed allowed by the universe, still centuries away from reaching us. And when it arrives, if it has already happened, or when it eventually does, the night sky will never be the same again. The familiar constellation of Orion, which has guided navigators for millennia, which has marked seasons for countless generations of farmers, will be forever altered. The hunter's shoulder will shine with impossible intensity, transforming the pattern we have known since childhood. Some astronomers believe, based on models of stellar evolution and observations of increasing instability, that we will see this supernova sometime this century. Perhaps in 10 years, perhaps in 50. Within the lifetime of people born today, within the living memory of present-day humanity. Others advocate a more cautious perspective. Their models suggest that Betelgeuse's core, despite all the external signs of instability, is still stable enough to continue nuclear fusion for millennia more. That the star may pulsate, vary, lose mass dramatically, but still persist far beyond any present human life. The truth is, we simply don't know for sure. Betelgeuse could collapse silently without apparent warning. One day it's there, pulsing normally, and the next, observers around the world begin to see its brightness increasing exponentially, realizing that the final event has begun. Or perhaps there are early warning signs. The star may dim slightly in the days or weeks before the big event, a subtle change in its behavior that only attentive observers would notice. Dedicated, professional, and amateur astronomers who monitor Betelgeuse religiously may have only a few hours or days warning before the supernova becomes obvious to everyone. And telescopes around the world are indeed monitoring its luminous pulse. Coordinated observation campaigns are tracking its brightness variations, spectral changes, any anomaly that might indicate the end is near. It's a global vigil, a collective wait for one of the most spectacular events that observational astronomy can offer. When the collapse finally begins, When the iron core reaches its critical mass and implodes, the first signal will not be light. It will be a flood of neutrinos, ghostly particles that interact so weakly with matter that they can travel light years through solid lead without being deflected. Neutrino detectors buried deep beneath the Earth, shielded from cosmic background radiation, will pick up this pulse of neutrinos minutes before the light from the explosion escapes the star's outer layers. It will be a warning whispered by the universe. Betelgeuse is dead. And then, minutes later, the light will come. The initial flash will reach Earth, and a new star will appear in the sky, growing in brightness over hours and days, eventually rivaling or surpassing the full moon. Imagine walking under the night sky and having two main sources of light, the familiar moon and this new blazing star on Orion's shoulder. Shadows would be cast, duplicated by these two sources. It would be like a strange, lingering twilight, a night that isn't completely dark. And when that happens, Betelgeuse will enter the history of modern astronomy in a way that few other stars could. It will be studied with every instrument available, at every conceivable wavelength. Billions of dollars worth of scientific equipment will be focused on this single point in the sky. The James Webb Space Telescope, with its incredibly sensitive infrared sensors, may be operational when Betelgeuse explodes. It could witness the final stages in unprecedented detail, seeing through the dust and gas that would obscure observations in visible light, revealing the physics of the explosion in real time. And the expelled material, those heavy elements forged in Betelgeuse's core, launched into space at significant fractions of the speed of light, will not disappear. It will disperse, mix with interstellar molecular clouds, and enrich star-forming regions. From there, millions or billions of years in the future, new stars will be born, incorporating atoms that were once part of Betelgeuse. And planets will form around these new stars. Rocky planets with iron cores that were created in Betelgeuse's final agony. Perhaps in a future so distant it's almost impossible to imagine, civilizations will be born on worlds made partly of Betelgeuse's cosmic dust, and perhaps they will look at the night sky from their worlds, see distant stars, and wonder about them, just as we do now. Perhaps they will observe our sun, if it is still burning billions of years in the future, and speculate about its nature, its destiny, whether there are worlds around it. A cosmic cycle of observation and wonder spanning ages. The death of a star can mean the birth of millions of new worlds. Each supernova is simultaneously an end and a beginning. Destruction that sows creation. It is the fundamental cycle of the cosmos: birth, life, death, rebirth. Betelgeuse is a profound reminder that everything in the universe is born, grows, and eventually disappears. Stars are not eternal. Galaxies evolve and die. Even the universe itself will have an end at some unimaginable future. Nothing is permanent. Everything is transient. She is living proof, and simultaneously dying, that the cosmos is in constant change. The universe is not static, frozen, immutable. It is dynamic, evolutionary, always transforming. The stars we see tonight are not the same ones that shone billions of years ago, and they will not be the same ones that will shine billions of years in the future. And one day, when Betelgeuse's light finally fades, whether in a year or 100,000 years, what will remain is its history. The memories of generations who observed it, the scientific data collected over centuries, the legends and myths that formed around it. Its story will continue to shine in the eternity of human memory and record, even when the star itself is just an expanding nebula and an invisible stellar corpse. Now, take one last deep breath. Let your mind absorb this journey past one of the most extraordinary stars in the sky. We journey from the incomprehensible vastness of Betelgeuse, a star so large that light takes more than an hour to pass through it, exploring its pulsations, its variations, its slow bleeding of mass into the surrounding space. We witnessed the great darkening of 2019, when the world thought that perhaps, finally, the supernova had begun. We learned about the forging of heavy elements in its core, about the inevitable moment when iron will become dominant and the collapse will be instantaneous. We contemplate its cultural significance through millennia, as a guide to the seasons, as a symbol of war, as a constant presence on the shoulder of the celestial hunter Orion. And we imagine the spectacle it will be when it finally explodes, transforming nights into twilight, visible during the day, shining like a second moon. Betelgeuse teaches us about scales that transcend human experience, in size, in energy, in time. It reminds us that we are part of a cosmos that is much larger, much older, much more dynamic than any human civilization. And it gives us a strange and wonderful hope that from destruction comes creation, that the death of stars sows the seeds of birth for new worlds, that perhaps future civilizations on planets not yet formed will look to their skies and marvel at the stars just as we do now. Betelgeuse is up there at this very moment, pulsing silently. Perhaps already dead, perhaps still living its last moments, perhaps persisting for millennia more. We don't know. And there is beauty in this uncertainty, in this waiting, in this collective vigil of a species watching the universe slowly change around it. Sleep well. Dream of dying giant stars, of light traveling through centuries, of explosions sowing unimaginable futures. Good night.